So today we discuss interpolation. Interpolation and extrapolation techniques are used to find the analytic function f of x that passes through the given set of data points and to use the function to evaluate for our desired value of x. It means interpolation and extrapolation are considered to be the techniques or methods that can be used to find the analytic function which can manipulate the given data sets to find the desired value which is not given in the data. These techniques are the foundation stone of many widely used applications in the field of science, economics, and engineering. So these methods are very useful and considered as the basics for applications in the field of science, economics, and engineering. Mostly due to limitations, the experimental results are performed with selected measurements, and these measurements are discrete in nature and hence are only available for selected conditions. So, mostly due to limitation, the experimental results are performed with selected measurements. Because of these limitations, we perform the experimental results with selected measurements. And these measurements are discrete in nature and hence are only available for selected conditions. So, due to the fact that these measurements are discrete in nature, so discrete means there are gaps, and so depends on the integer nature because after 1 there is 2 and in between 1 and 2 there are many points. So that is why we can say that discrete nature. Discrete nature because of gaps between the integer like nature. So but to find a general function or an approximate function, values are required for intermediate conditions as well. So to find the general function which can be fit over the given data or an approximate function, values are required for intermediate condition as well. So to find the value which lies in between the given data, we require the values. Interpolation and extrapolation has application in different areas. For example, the weather data center measures temperature for every hour of a day. So one of the example of interpolation is the data collected by weather data center, so which they collect after every hour in a day. But if we are interested to estimate the temperature for unknown values, like every 30 minutes, or to estimate the temperature for the next day, we use interpolation or extrapolation. So in this example, we are given the data which has collected after every hour in a day, but we are interested to find the data which is collected after every 30 minutes or maybe for the next day. So now the prediction of these unknown intermediate values within the data range is called interpolation, and the estimate of data points outside the range is called extrapolation. So now these intermediate values are not given, but we are given the discrete values which have been collected after every hour of a day, and we are interested to find the values after 30 minutes or one day. So these values are not given. That is called intermediate values. So if we predict these intermediate values based on the given data, then this is interpolation. Another way to understand the interpolation is that a census of the population of a region is taken every 10 years as shown in the following table. So a census has been taken place after every 10 years and the data has been collected in the form of this table. So in the table, in year 1950, the data is collected as 151, 100, 100,000 and 326. And in 1960, 179, 100,000, 323. So this data is collected after the census. We might ask whether the available data could be used to provide a reasonable estimate of the population, say in 1975 or even in the year 2020. So observe the table. So data for the 1975 is not given in the table. But if we predict the data corresponding to this year, that will be called interpolation because this is the intermediate value between 1970 and 1980. So, but if we are interested to find the data corresponding to the year 2020, so this is outside of this range because we are provided the data up to 2000, okay, but we are interested to find the data for 2020. So that is why if we predict the data for 2020, this will be called as extrapolation. So such type of predictions could be obtained by using a function that fits the given data. So it means first we have to construct a function which manipulate the given data. For example, if we take the domain points 1950, the function should return the value 151, 326. And for the value 1960, the function has to return the value 179, 323. So if we construct the function which manipulate the given data, then we will use this function to predict the data which is not given. So such type of predictions could be obtained by using a function that fits the given data. This process is called interpolation. In addition, consider the following table. The process of finding f of 4.2, f of 6.2, or f of 7.5 is called interpolation. Why this is interpolation? Because if we observe in the table, the domain points are 4, 5.6, 7.2, 8, and the range points are 7, 40, 98, and 32. So at the very first step, we will construct a function which fits the data. For example, if we take 4 as an input for the function, it must return 7 as the output. And if we take 5.6 as the input, so it must return 40 as the output. And if we take 7.2 as the input, it has to return 98 as the output. And for 8, it has to return 32 as the output. So first we will construct the function which manipulate these values exactly as given. So finding f of x such that x lies between x0 and xn. It means x must lie between the initial value and the final value. So here is what is the initial value. Initial value is 4 and final value is 8. So if the prediction values lies between 4 and 8, so then we can call it interpolation. Okay. And if the prediction values or the values to be predicted lies outside this range 4 and 8, it will call extrapolation. So where is the process of finding f of x such that x lies outside the initial and the final value? it means x should be greater than 8 and should be less than 4. So then the process of finding values outside this range will be called extrapolation. So therefore finding f of 3, f of minus 2, or f of 8.1, or f of 10, etc. is categorized as extrapolation. So next is the polynomial interpolation. Polynomial interpolation consists of determining the unique nth order polynomial that fits n plus 1 data points. Polynomial interpolation consists of determining the unique nth order polynomial. So it means if we are interested to construct a polynomial of degree n, we must have the data n plus 1. So for example, so here is the data is 1, 2, 3, 4. So 4 points are given. So we can construct a polynomial of degree 3. Okay. So this polynomial then provides a formula to compute intermediate values. Although there is one and only one nth order polynomial that fits n plus 1 points, there are a variety of mathematical formats in which this polynomial can be expressed. So this polynomial then provides a formula to compute intermediate values. So it means first we will construct a polynomial of degree n, and to construct a polynomial of degree n, we required a data points which is n plus 1. So this polynomial then provides a formula to compute intermediate values. Although there is one and only one nth order polynomial, so that fits n plus 1 points, there are a variety of mathematical formats, so in which this polynomial can be expressed. Our two alternatives that are well suited for computer implementation are Newton and Lagrange polynomial. Our two alternatives that are well suited for computer implementation are Newton and Lagrange's polynomial. So these two kinds of polynomials are very famous and useful. So here we can repeat it again. Polynomial interpolation consists of determining the unique nth order polynomial that fits n plus 1 data points. This polynomial then provides a formula to compute intermediate values. Although there is one and only one nth order polynomial that fits n plus 1 points, there are a variety of mathematical formats in which this polynomial can be expressed. Our two alternatives that are well suited for computer implementation are Newton and Lagrange's polynomial. The problem of determining a polynomial of degree 1 that passes through the distinct points x0, y0 and x1, y1 is the same as approximating a function for which f of x0 is equal to y0 and f of x1 is equal to y1 by means of a first degree polynomial interpolating or agreeing with the values of f at the given point. So if you remember, this is the property of 1, function or injective function. So it means the problem of determining a polynomial of degree 1 that passes through the distinct 2 points is the same as constructing an injective functions passing through the same points. Okay, injective function or 1, function means by means of first degree polynomial interpolating or agreeing with the values of f at the given points. So it means if we are given 2 points, we need to construct a 1, function that manipulate these 2 points. Or in other words, we need to construct a polynomial of degree 1 that can manipulate these 2 given points. So using this polynomial for approximation within the interval given by the endpoints is called polynomial interpolation. So if we use this polynomial to further manipulate or to predict the data, that we call polynomial interpolation. Here is an example. Suppose we want to find a polynomial that passes through 3 points. So it is very clear that if we are interested to construct a polynomial that passes through 3 points, it means this polynomial will be of degree 2, or we can call it quadratic polynomial. In other words, we want to find a polynomial p such that p of 0 equal to 1, p of 1 equal to 3, and p of 2 is equal to 2. So what are the points of the domains? Points of the domains are 0, 1, and 2. So in this ordered pairs, the first points represent to domain. So this is 0 is the domain, and then 1 is the point of domain, and then this 2 is the point from domain. So that we also consider as the inputs. So these are the inputs. If we take this 0 as input, 1 as input, and 2 as input, the function or the polynomial must has to return 1, 3, and 2 as the outputs. So that is why uh, this polynomial should be on the points p of 0 equal to 1, p of 1 equal to 3, p of 2 is equal to 2. For 3 points, it is natural to try and accomplish with a quadratic polynomial because to construct a polynomial of degree n, we need n plus 1 data points. So here, because 3 data points are given, it means the resulting polynomial must have a degree 2. So assume that p of x is equal to c naught plus c1x plus c2x square. Here you can also consider as the quadratic polynomial ax square plus bx plus c. So it depends on you. So how you will construct this. So if we suppose that this is the required polynomial, so then substituting values in polynomial 5.1, we obtain 3 equations. P of 0 is equal to C of 0 is equal to 1. So you have to replace x with 0. So replace this x with 0. So P of 0, this will be 0, and this again will be 0, the third term, and we are left with P of 0 is equal to C naught, and P of 0 should be equal to 1. It means C naught is equal to 1. And for next P of 1, we have to evaluate P of 1. So replace x with 1. So put here x, it will be C1 into 1, C1, C2 into 1, C2. So we will have the equation C naught plus C1 plus C2 is equal to 3 because P of 1 is equal to 3. Next, we will substitute this 2, P of 2. So replace x with 2. So C naught plus 2C1 plus 4C2. So C naught plus 2C1 plus 4C2 is equal to 2. So then substitute this C naught is equal to 1 here. So you will get this C1 plus C2 is equal to 2 because this 1 will be subtracted from 3. So you will have this equation C1 plus C2 is equal to 3, and similarly 2C1 plus 4c2 is equal to 1 because c naught will be subtracted from these two. So now you will have these two equations. C1 plus C2 equal to 2 and 2C1 plus 4C2 is equal to 1. Okay, so then you can divide this equation with 2. You will get this C1 plus 2C2 is equal to 1 by 2, and here you have already C1 plus C2 is equal to 2. So then you can subtract these two equations. So you will have uh, 2C2 minus C2, it means C2, and then you have this 1 by 2 minus 2. So you will have the value of C2 is equal to minus 3 by 2. And substitute this here because C1 plus C2 is equal to 2. So you will get the value of C1. So following polynomial will be obtained, which is P of x is equal to 1 plus 7 by 2x minus 3 by 2 x square. That is the quadratic polynomial. And what is the remark? One of the most useful and well-known classes of functions mapping the set of real numbers into itself is the algebraic polynomial. One of the most useful and well-known classes of functions mapping the set of real numbers into itself. So again observe that one of the most useful and well-known class of function. So that is very useful class of function mapping the set of real numbers, so which can map real numbers into itself. So it means the domain of these numbers are real and the range of these numbers are real. So if a function maps from real numbers to real numbers, it must lie in the class of function which map a set of real numbers into itself, is the algebraic polynomials. So this is called algebraic polynomials. The set of functions of the form Pn of x is equal to an nth degree polynomial. So this is an nth degree polynomial a naught plus a1x plus so on. We can write like this way n xn plus a n minus 1 xn minus 1. Okay, so it's nth order polynomial you can say. So where n is a non-negative integer and a naught so on a n are real constants. One reason for their importance is that they uniformly approximate continuous functions. By this we mean that given any function defined and continuous on a closed and bounded interval, there exists a polynomial that is as close to the given function as desired. So again we can repeat it. One of the most useful and well-known class of functions mapping the set of real numbers into itself is the algebraic polynomial. The set of functions of the form, okay, where n is a non-negative integer and a naught to a n are real constants. One reason for their importance is that they uniformly approximate continuous functions. By this we mean that given any function defined and continuous on a closed and bounded interval, there exists a polynomial that is as close to the given function as desired. So remarks, another important reason for considering the class of polynomials in the approximation of functions is that the derivative and indefinite integral of a polynomial are easy to determine and are also polynomials. So it means the derivative of a polynomial is again a polynomial, and integral of a polynomial is again a polynomial. So that is why we can say that another important reason for considering the class of polynomials in the approximation of functions is that the derivative and indefinite integral of a polynomial are easy to determine and are also polynomial. So that is the main reason to use these polynomial as interpolating formulas or use for interpolation. So for these reasons, polynomials are often used for approximating continuous functions. So that is the reason, or these are the reason, so they will use polynomials to approximate continuous functions. So next is the theorem, Weierstrass approximation theorem is that suppose that f is defined and continuous on AB. So here we have to suppose that the given function must be continuous on the closed interval AB. So suppose that f is defined and continuous on AB. For each epsilon greater than 0, there exists a polynomial p of x with the property that f of x minus p of x absolute value less than epsilon. So what does it mean? It means that there is a very small difference between the function and the polynomial constructed to manipulate the data. Or we can say that we can minimize this difference between functions and p of x polynomial that could be minimized as we desire. Or we can say that to manipulate the data or to interpolate the data, it's the same thing if we construct a function f of x or a polynomial over the given data. So that's what this theorem says. Weierstrass approximation theorem suppose that function f is defined and is continuous on the interval AB. So there exists an epsilon greater than 0, okay, and also a polynomial corresponding to epsilon with the property that the difference between this function and the polynomial can be minimized or can be considered less than the epsilon. Okay, so that is what we want to say for this interpolation. So again,